video. Okay, so on your paper, you should have at the very top, you should have written keep these notes and then the title end of Unit 1 test review. Okay, so for number 1, write a meaningful summary phrase for each algebraic expression described. If C represents the number of cakes ordered, so let's write this down for 1A. So on your paper, put 1A. And then let's write C equals cakes ordered. So on your paper, you're writing 1A, and then you're writing C equals cakes ordered. And then it says, and P represents the number of pieces per cake. So let's write down P equals pieces per cake. Then what does C times P represent? So let's write that down on the paper. C times P represent question mark. So on my paper so far, I have you guys see my paper? Because I have it connected to or attached to a table, like a card table. So it's me bumping the table. I'll just try to keep it still. Okay, so this, oh, then I jiggle it. All right, so this is what you should have on your paper. It's too blurry. Try to zoom in a little bit. Is that better? Okay. All right, so this is what you should have on your paper so far. Everybody good? All right, I'm gonna bump back over to the test. Okay, what does C times P represent? Hint, what would a numerical answer be labeled? What is the name of the quantity we would end up with after the total cakes and the number of pieces of cake were multiplied? Okay, so what we're looking for here are some words to describe what this means. So if we have C is the cakes ordered and P is the pieces per cake, what happens when we multiply those together? What does that represent? Does anybody know? Very good. Yeah. The key word there is going to be total. Yeah, the total pieces of cake that we ordered. So for example, if you had, so write this down as an example so you can clearly see it. If you had 2 cakes and there were 6 pieces per cake, and we're multiplying those numbers together, 2 times 6 equals 12 what? What does 12 represent? That's going to be our total pieces of cake. So what does C times P represent? The answer there is going to be total pieces of cake. Okay, we good? Okay, now for 1B. If D represents the cost of a dozen donuts, so let's write that down. For 1B, we've got D equals cost of dozen donuts. Then what does D divided by 12 represent? Okay, so on your paper, you should write D divided by 12 represent, question mark. Very good, Troy. Yep, that's exactly right. Did you guys get that? So if D is the cost for a dozen donuts, here's our cost. And then what does a fraction line mean? What operation is that? Division, divided by. That's right. We're going to divide. So we're going to take that cost and divide it by 12. Why are we dividing it by 12? Okay, 12 people, or what? How many is a dozen? A dozen is 12. That's exactly right. This is going to be the cost of each donut. You take the total cost and you divide it by how many you have. It's going to be the cost per donut. Very true. Okay, do we ever get Dela, Tara, Edgard, Hayden, or Joshua to show up? Sorry, Giselle, I don't know what to do about the cutting out. I don't know if it's on my end or your end. All right. So for number 2, evaluate the following expression for R equals -4, S equals 5, and T equals 10. Remember PEMDAS and the rules about multiplying and dividing negative and positive numbers and adding and subtracting negative and positive numbers. All right, so for number 2 on our paper, let's write down R equals -4 and S equals 5 and T equals 10. And then let's go ahead and write down our A and B expressions. So I know that is super duper small, but for A, that says T over S plus R. It's written way too small. And then for b, it says s squared plus rt. It's an s squared. Okay, so now we can just start taking these numbers and plugging them into the expressions. So let's start with our t. We know that t is 10. So let's write that down, 10. And then we have our division line. And then we have s, and s is 5. And then we're going to be adding r, and r is a negative 4. Mm-hmm. Very good. Yep, it's the same thing as 10 divided by 5. So 10 divided by 5 is 2. So now we have 2 plus a negative 4. So if you think of a number line, positive 2, that's going to go up 2. But then we have a negative 4, so we're going down 4. Where are we going to end up? Negative 2. Very good. All right, for s squared, s is 5. So we'll write down 5 squared plus r, and r is negative 4. And then t, and t is 10. So can I just go ahead and write it like that? Does that make sense? How come? Exactly. Yeah, this looks like I wrote negative 410, which is not the case. We got to be multiplying these two. So one of them, and it doesn't matter which one, and you could even put both in parentheses if you want to, but one of them needs to be in parentheses to show that they are sitting right next to each other. And sitting right next to each other means what operation? Mm-hmm. Mm-hmm. Yep, we could do that first. And since it's separated by a plus sign, we could actually take care of both of these at the same time, because that's what we're going to be doing last. So what is 5 squared, or can somebody tell me what 5 squared means? 5 times 5, that's right. This is our base of 5, and we're multiplying it by itself 2 times. So 5 times 5, which I heard the answer, 25. And then plus negative 4 times 10. Negative 44, negative 40. Okay, first let's talk about positives and negative. We have negative times positive, which is going to give us a positive or negative. Remember, they're opposite signs, so it'll give us a negative. Okay, and then what's 4 times 10? 40. Okay, so last step, 25 plus a negative 40. Got to go up 25, but then down 40. Or you could think of it as 25 minus 40. Very good. Negative 15. Okay, and let's go back to our test. Okay, for number 3, use the distributive property to write each expression in an equivalent form. I'm not looking for the numerical answer, only another way to write the problem. So we practice this a little bit in some of our lessons. We're not looking for the answer here. We're looking for you to write different ways of showing the distributive property. So I'll show you how this is done. And like I said before, this review is very, very, very similar to what you guys are going to see on the actual test. So make sure you're taking good notes so you do this correctly. All right, so this is number 3. And for number 3, let's just write distributive property So for number 3, write the words distributive property. And then let's go ahead and write down what we see on the screen there for A and B. Okay, so writing the distributive property in another equivalent form without actually solving here. Remember the distributive property, I'm going to jump down to B. Distributive property is where we multiply what's outside the parentheses into the parentheses. So I'm actually going to do B first here, just because it's a little bit easier to explain. So when we multiply 10 into the parentheses with 3, we are going to have 10 times 3. So let's go ahead and write that. 10 times 3. And because there's a plus sign right there, we're going to be adding. Add that on to 10 times 4. And this right here is the answer that we're looking for. You can even make yourself a little note. Write it like this. So you don't forget. Remember, you're not solving it. Okay, now let's take a look at A. So A looks really similar to what I just wrote right here for B, for the answer for B. Take a close look at A. Do you see a number that we could pull out of both of those parentheses? Mm-hmm. Let's pull that 3 out. Okay, so what's going to be left inside the parentheses? Yep, 10 and 20. Yeah, and look what's right in between. Plus sign. So this is going to be 10 plus 20. So remember, you're not solving this. You're just writing the distributive property in an equivalent form. So go ahead and underline this and make yourself a little note to right answer. Did not spell that right. Right answer like this. Okay, guys, I need to go get a drink of water. So everybody get up off your butt, stretch your arms up over your head. Go get a drink of water so we can do some more. And then did Dela, Edgard, Hayden, or Josh ever show up? Nope. Okay. Okay, you back? All right, let's go back to the test review. Okay, for number 4, an input-output machine generates the table shown. All right, on your paper, go ahead and copy down the input-output table. So this is number 4. Make sure you write input and output and your X and your Y so it's labeled correctly. Okay, so I think the first thing it asked us to do was figure out the missing numbers in the table. Well, on the input side, looks like we're just counting up by ones, right? Okay, so should be a 2. 4, 6, 8, and then jump to 12. What should go in between? 10. So it looks like we're counting by 2s over here. Okay. So that, I mean, that was easy enough. But then I think after complete the missing entries, then it's write a rule that describes the relationship between the input and the output. Output variable goes first. Okay, so for B, it says write a rule. So on your paper, put B, write a rule. Okay, so remember, output variable goes first. So it's kind of like saying the output equals, and then something that we're going to do to that input number. So let's think about this. How can we go from a 1 to a 4? How can we go from a 2 to a 6? From a 3 to an 8? And remember, sometimes there's 2 steps involved. So sometimes you have to like multiply first and then add something on. So play around with some numbers and see if you can figure out what we have to do to each input number to get to the output number. And you could play around with any of these. You can start with like 1 and say, how can I get from 1 to 4? Well, I know I can add 3 on, right? So if we add 3 on to 2, 2 plus 3 is going to be 5. So we know that rule won't work. Okay, Alan is saying to multiply by 2 first and then add 2. All right, let's check his work. So 1 times 2 is 2, and then add 2, that's going to be 4. So far, so good. All right, let's try it to this one. 2 times 2 is 4. Add 2, we get to 6. All right, and we don't have to check every single one, but checking 3 would probably be good. Let's skip down here. So 5 times 2 is 10, plus 2 gives us 12. So it looks like we found the rule. So what we're going to write here is output equals. So to get our output number, we're going to take our input number and multiply it by 2. And the best way to write that is put the number first, 2, and then in parentheses write input, and then add 2. So output equals 2 times input plus 2. And after you do this, you can easily rewrite this rule using the variables. So our output is y. We'll have y equals 2 times our input. So that's going to be 2 times our input is x. 2 times x, or 2x. And then plus 2. So that is our rule. All right, let's go back to our test. Okay, and then we have C. C says, what is the value of the output when the input is 20? Explain how you found your answer. Okay, we want to know the value of the output when the input is 20. Okay, we know the input. The input is 20. So all we have to do is put 20 where the input goes. So this was for C. So we're looking for the output. Output is y. Y equals, and we know the input is 20. So we're going to have 2 times 20, and then plus 2. Okay, so then we're going to end up with y equals 2 times 20 is 40 plus 2, 42. So that means the output equals 42 when the input is 20. So then it said, explain how you did it. So here's some easy points. Just don't forget to do it when you're doing your test. Explain how you did it. You can say something simple like, I put 20 in for the input. Then calculated. I put 20 in for the input and then calculated. Okay. And then D. What is the value of the input when the output is 85? Okay, so this time we have the output. Output is 85. All right, so for D, we can take our equation, y equals 2x plus 2, and we know the output is 85. Where would I put the 85? Uh-huh. Yep, the y is our output. So we're going to put the 85 for the y. So we can rewrite this 85 equals 2x plus 2. And now we need to work backwards to get x all by itself so we can figure out the input. All right, so draw a line down. Find your variable and whatever's attached to it. Circle it. We're going to save that for last. Okay, anybody see the first step we're going to do? Yep. Let's get rid of that 2. So it's a positive 2 or plus 2. So we need to subtract 2 to get rid of it. So that's gone. What we did to one side, gotta do to the other. So now we'll have 83 equals 2x. And what does it mean when 2 and x are sitting right next to each other?
That's 2x is the x.
Right, them sitting right next to each other means multiply. So to get rid of it, we're going to have to divide. So we're going to divide by 2. And what we did to one side, got to do to the other. 83 divided by 2. 41.5 equals x. Okay, and then here's that easy way that you guys are going to lose points if you forget to do this. It said explain. Explain how you did it. So what did we do first with the 85? Okay, before that even, before we even did this. Okay, exactly. Yeah. Not input as the output. Yeah. Yeah. Okay, so put 85 in for the output, then calculated. Put 85 in for the output and then calculated. Okay. All right. So for this one, we are going to be doing this in Desmos, which I'm going to show you how to do in just a sec. So that's for number 5. So I'm going to skip past it for just a second and go to number 6. And that's the last one. Okay. Okay, so for number 6, find the rule for the input-output table. Fill in the process column to help you write your rule. Remember, the rule must start with the output variable. In this table, the output variable is y. So let's go ahead and copy down this table on our paper. Remember to label your x input and your y output. And I would leave some space in between so we can write that process. So make your table kind of long on your paper like you see on the screen. Okay, so it said, remember to start the process with our output. So let's write down output equals. And this is going to show right here how we get from 1 to 0, how we get from 2 to 2, how we get from 3 to 4, from 4 to 6, and 5 to 8. So it looks like we are counting up by ones over here, and then counting up by twos over here. Okay, so I'm gonna let you guys think about this for a minute. What would you have to do to get from 1 to 0, from 2 to 2, from 3 to 4? And don't forget, sometimes you have to do 2 steps. Sometimes you have to like multiply and then add, or multiply and then subtract. And I'm going to give you a little hint. When you're counting up by ones on the input, take a look at the change that's happening here. From 0 to 2, from 2 to 4. What's the change that's happening? It's going by 2. We're adding 2. Okay. And if I could write, adding 2. And over here, what are we going by? By 1. We're going up by 1. Okay, so if you take the change in y over the change in x, so what's our change in y? Positive 2, adding 2, yep, 2. And our adding 1. What is 2 divided by 1? 2. Okay, so this is our change that's happening. And you can take this number and multiply it with x. And it will always be true. You can multiply this change that's happening with x, and then you'll probably have to do something else to make the process complete. So here's your, it does not. You got to do something else, don't you? What is 1 times 2? 2. And then how would you get down to 0? Minus 2. Okay. So that will work for the first one. Now you guys try it out. Nobody say anything. You guys try it out. Try the next one. Multiply by 2 and then subtract 2. Try the next one. Multiply times 2 and then subtract 2. Nobody shout out anything. Let people think about it for a minute. All right, guys, does it work for all of them? Yeah. Okay, so for our process, this is what we're going to be multiplying with x, or multiplying with our input. So write the number first. 2 times our input. And then what did we have to do after that? Subtract 2. And I think they left all these lines so you could write it over and over again, which I don't feel we need to because we can check a couple of them. 2 times 5 is 10. Oh, okay. Yeah, we could do that. Instead of writing output and input though, why don't we use X and Y? So our output is what? X or Y? Our output is Y. So Y equals 2 times our input, which is X minus 2. Or you could write it with the numbers like Troy said. So our output is the number 4 equals 2 times 3 minus 2. And we can write the others with the numbers also. So start with your output. 6 equals 2 times 4 minus 2. And then 8 equals 2 times 5 minus 2. So it'll be a little repetitive because we totally just wrote the rule right up here. But on the test, it does ask you to write the rule. So for the rule, we have output equals 2 times the input minus 2. And we know our output is Y. Y equals 2 times our input is X minus 2. So I will accept either one of these answers for the rule. You can put X in parentheses if you want to, but what does it mean when the 2 and the X are sitting right next to each other? It means multiply. Yep. So for the X, parentheses won't matter. The only time it really gets confusing is when you're putting a number in for X and you end up writing the numbers right next to each other. Then you'd want to put or X times 6, you could just write it as 6X. Okay, at this point, I'm going to go ahead and stop and let you guys turn in your notes into Canvas so you can have a free A for today. So you can go ahead and take picture or take a video. If you take a video or a picture with your laptop, I think you'll have to hang up in the Meet and go submit it in Canvas and then come back into the Meet. So if you want to go get your free A right now, you don't want to wait till later, go ahead and take a picture or video and then post it into Canvas. You're going to be putting it right here. Test review notes. Oh, and I made this worth 10 points for you. Give you a nice little boost. So you can go ahead and submit your notes right now if you want to. Why don't we meet back? It's 11:04. Let's meet back at 11:10. Make sure you are back into the Meet at 11:10. So if you want to go post your notes right now, go for it. For any of you who showed up late, or if you had like any internet issues or whatever, and you just didn't get all of these notes, why don't you go ahead and send me an email right now? And I will, hang on a second, I'm gonna stop this recording. And I will send you this video as soon as I have it for you.